Hello, STEM Nation. Jeff here, and welcome to episode number 33 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear, please share it with a friend. Now let's get fired up with our guest, Jonna, and I hope our chat will help ignite your passion towards a STEM career. Jonna Gerken earned a Bachelor of Science degree in Industrial and Management Engineering and an MBA in Technology Development from Rensselaer Polytechnic Institute. She currently works at Pratt Whitney, which is an aviation and aerospace company managing manufacturing engineers. Jonna is also the president of the Society of Women Engineers, known as SWE. Welcome to the show, Jonna. Fill in any gaps and share a bit of your personal life.
Yeah, I did get my degree from RPI, which is up in Troy, New York, many years ago. And since then, I've had a really exciting career, mostly in the area of manufacturing. I actually started at another company, so haven't been at Pratt my whole career. I started at another company called Colts Manufacturing. Yes, the maker of handguns and rifles. Even though I knew nothing about it, it was a great experience learning about how things are made. At the time when I was in undergrad, we didn't have a lot of opportunities to take specific manufacturing classes. There were very few, and I didn't really know I wanted to go into that. But getting that job at Colt was really eye-opening to the exciting world of manufacturing. After I left Colt, I moved to Pratt, and I've been there 18 years.
All right, Jonna, thanks for that great overview. And we're going to dive right in here. And so you've got a pretty diverse background at Pratt Whitney. You've had multiple jobs there, which is, I guess you've been involved with manufacturing, and I'm guessing since it's avionics, it's a high reliability type environment. Could you help STEM Nation understand what type of job opportunities would be available in industrial engineering and maybe relate it specifically to the avionics world?
Sure. The aviation world is pretty large. It's like any industry. There's a lot of moving pieces to make it all work. The engines that you typically see on airplanes now, have hundreds of thousands of pieces on them. And so it takes a large team of people to make sure that it works, reliably, so that your plane takes off and lands every time. The number of opportunities for industrial and manufacturing engineers are pretty broad. That is the beauty of those degrees, is that we have lots of folks who have stuck to the traditional roles in those different fields of, industrial engineers typically focus on how our processes work and making them more efficient and more effective. And the manufacturing engineers certainly help make sure that the processes themselves are clearly identified and work well for the design's intent. However, a lot of those folks do move on to different opportunities, whether it's staying in the operations world and moving up through our leadership team in operations that's leading either cells or the business units themselves, or even leading a whole organization in operations. And some folks like myself actually go back to what we would call the design engineering organization, the folks who actually design the parts and create the different parts so that they can be made. It's a great way to understand both sides of the organization, that what you put on paper doesn't always translate well into a makeable design, a manufacturable design, and vice versa, that things that we might want to make need to be designed differently based on the process capabilities we have. There's a lot of opportunity on both sides of the fence, like we like to say, and it's really exciting nowadays with lots of new technologies that are coming on board.
So being on the manufacturing side, working with design engineering, are you basically assuring that whatever the design engineers are designing would be manufacturable and reliable?
Exactly. And not just one time, but hundreds of thousands of times, because most of our engines are in the field for at least 40 years, if not more. So we have to be able to make parts over and over and over again the same way every time. And that's what's really important.
So speaking of making parts, I mean, there's the traditional manufacturing processes, but with the advent of 3D printing, do you see 3D printing becoming a major impact in design of aircraft or high reliability systems?
Yeah, we're seeing a lot of push towards that. The key to understand is that there's certain types of parts that are more beneficial to 3D printing and other similar technologies, and some that are not. So it's not going to be a full on let's change everything over, but there are definitely types and classes of parts that have the right design in order to take advantage of 3D printing technologies, and some that are not. So we're looking at both.
So for somebody interested in the manufacturing side, is industrial engineering one of the only ways to go, or could they come in through another direction?
No, not at all. So we have folks, most of our manufacturing engineers actually come up through mechanical engineering, some through industrial engineering, others through aerospace. So there's lots of different varieties. It's really about problem solving, being able to really take time to understand the problem and come up with some solutions, creative and traditional, as well as wanting to work in that environment, in that day-to-day manufacturing environment where you're out in the shop floor, you're interacting with people. It's not just sitting behind a desk.
So for somebody in high school thinking about a STEM career who's like, geez, I really don't want to just sit behind a desk and do things. I want to be out and about. It sounds like maybe industrial engineering or the manufacturing side may be a good opportunity for them.
Absolutely. That was one of the things when I was an undergrad that I knew that I didn't want to do, which is why I chose industrial engineering. I wanted to be able to be out and about interacting with folks, whether it's operators or designers or other people in the operations environment, and trying to make a real difference, a tangible difference that you can see even after a day.
Now let's dig into your specific area of expertise. What would you describe that as?
That's a tough one because I've actually become more of a generalist than an expert in any one field. But if I had to answer that, I'd say technology development is where I do spend a lot of my time. Most of the roles I've had have been developing new either technologies or new processes that may or may not support a new technology, but being able to do something for the first time and set the standards and set the process for how things are going to get done, I find more interesting than maybe going out later and either trying to improve an existing one or work within the confines of an existing process.
So Jonna, a student that's graduating college and wants to go into the manufacturing side, what would a typical day look like? What would they do on a day-to-day or a week-to-week basis?
They would expect to be working hard, getting confronted with lots of issues and problems that they need to help solve. And the great part about it is it's never by yourself. It's always in a team. So there's always going to be a group of people working for these problems. And it might be you and a designer and another manufacturing engineer or a special process engineer. It could be any number of different types of folks that you'll have to work with. As long as you are excited to go out in the morning, check out what's going on in the shop, come back, do some investigative work and some research into the different options, and then go back and talk it out. I think one of the maybe more intimidating things about manufacturing, which folks should understand, is you're going out there and you're going to be working with operators who maybe have 10, 15, 20, 30 years of experience. And that experience is very important, and it should never be overlooked. Listening to the people who make the parts every day and really trying to find out what problems they're having and what ideas they have to solve it really is worth the time, because they do it every day. They understand where the issues are, and their knowledge is really invaluable to coming up with a solution that not only works for the part, but that works for the person who has to make it.
Great insight, Jonna. If you're working with somebody and you're going to come in and you think that you know all the answers for somebody that's been doing it for 30 years, you're going to have a rude awakening.
Exactly.
You want to take their advice, heed that advice, and implement what they're saying and come up with the best solution.
Mm-hmm.
We're going to move over here, Jonna, to what has you really fired up in the industrial engineering space or in manufacturing?
What really has me fired up is all the great new technology that's out there. We are doing things now that we couldn't even imagine doing even 10 years ago. The ability to make parts out of materials that didn't exist before, or to create designs that weren't physically possible, or to make parts at a less expensive cost than we ever thought possible is really due to all the great new technologies that are out there. And the fact that the old adage of manufacturing being dirty, dark, and dangerous is really not there anymore. Most of these shops are beautiful, clean environments, very bright and welcoming and very well organized. And that's the kind of environment that gets you really fired up to get into every day.
Yeah, and Jonna hit on something there. In pretty much every STEM career, this has come up in multiple podcasts, is that we're working on things that didn't exist when we were in high school or in college, and you're going to continue to have continue to learn through your entire career. And if that's intriguing to you, a STEM career would be a good choice for you.
Absolutely. About 10 years ago, one of my roles at Pratt was working in composites, and I knew nothing about composites, and neither did anyone in the group really, but we all had to learn it very quickly in order to come up with some new designs. And it was a great learning experience for all of us that even to this day, with new products coming out and the rise of composites in aerospace, at least I know a little bit about what's going on, and I can, speak intelligently about it if necessary.
Jonna, and we are going to move into an aha moment. If you could take us to a moment in time where you've had an incredible aha moment that you think would help STEM Nation. Sure.
I actually have a great one. It was back when I was in high school. I actually wanted to be an architect. I had an uncle who was an architect, and I knew what it was, and it sounded really interesting. And, I kind of liked math and science aspect, seemed to fit well. And I spent the summer at a program, like a summer immersion program in architecture. And one of our midsummer projects was to design a building. There was a bunch of parameters and rules. And as I'm working on my building and making sure it's, in my mind, useful and practical and, can be made and, withstand the test of time in an earthquake or whatever other natural disasters, I looked around at my classmates and I saw nothing like that. I saw very elaborate, interesting designs and really out there building structures that they were going for the aesthetic more than the functionality. And that's when I think I realized, maybe architecture might not be the way for me to go. And fortunately, somebody did say to me, you know what? If you're thinking function, practicality, and all those things, maybe engineering might be the right thing for you.
Yeah, that was good probably to figure that out in high school.
Yep.
Versus going for 4 to 6 years. And yeah, so that's a great aha moment. I appreciate that, Jonna. And we're going to now transition to what it takes to get through college. You've been through the curriculum. It's challenging. If you could go back to when you were in high school again, heading off to college, what are some things that you wish you knew or you knew back then that you think would help STEMers launch into college successfully?
Yeah, I think the stereotype of engineering needs to be debunked. There's lots of engineers, very successful engineers, that really don't love math and science like you would tend to believe. And there's plenty of really well-established engineers who did not do great in high school or undergrad. But the reason that they are successful now is that they kept trying and they kept working hard, because problem solving in itself is not something that everybody is great at, but everyone can work hard and become great at, because you solve problems every day and you probably don't even realize it. So understanding the engineering method, similar to the scientific method for solving problems, that's really what it is at the foundation. But working hard is really a sign of a good engineer versus it coming easy, because it's not always going to come easy. Most high school students that are at the top of their class, it probably came pretty easy to them. And they'll get to college and they'll be with a bunch of folks like them. And then suddenly they're not the most intelligent person in the class, or they're not the best at everything because you're surrounded by everyone else who is the best. But those who continue to work hard and really understand that is what's more important than how easy it is, those are the ones who become successful in the end.
So turning our attention now to the attributes that you think STEMers need as they go from college into their careers, what do you think is important?
Curiosity, lifelong learning, perseverance, really understanding that engineers are needed everywhere, and the mindset is what's important. The hard work and the dedication really does pay off, because everything around you was invented or engineered by somebody. Nothing that we do today that we put our hands on or we use in our lives came out of nowhere. It all came from engineers. So it's important to remember that there are no wrong answers. There are no necessarily wrong career paths. Everything will work out if you continue to have those basic engineering skills.
Jonna, thanks for that great insight and the overview. And we're going to take a quick pause to thank our sponsor, Audible, who is offering a free audiobook. You could head over to STEMonFirebook.com. That's STEMonFirebook.com to get a free audiobook of your choosing. If you decide to cancel within 30 days, there's no cost, and you keep the audiobook. And we are heading to the lightning round. Jonna, are you ready?
Absolutely, Jeff.
All right. What is the best piece of advice you've ever received?
To always leave a legacy.
And how could you leave a legacy?
So doing something that lasts in the role that you're in, whether it's a new document or a new thought process or in manufacturing's case, a revised process, or anything that goes with your role, leaving something that people will say, hey, she did that before she left, and it really was valuable to our organization.
And what's a personal habit that contributes to your success?
Being very well organized. Now that I'm a manager, being organized is very important. Lots of emails, lots of phone calls, lots of meetings, and you have to really understand prioritization and organization.
And what is your favorite internet resource or phone app, and why?
Actually, right now, my favorite is Venmo. It is an online payment app because with the babysitters and other childcare needs that I have, it's a lot easier to hit a button to pay people than writing a check.
And what is one book you recommend, personal or business?
It's personal interest. It's called How We Got to Now by Stephen Johnson. 6 innovations that made the modern world. It's a very quick read, and it's a great overview, again, of how things don't just happen. Somebody has to connect the dots to make new technologies and new understanding of how the world becomes a better place. He has some really great insights into some basic technologies that we take for granted for right now.
Jonna, as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we'll say goodbye?
To work hard, don't give up, and really, if you want to be an engineer, there's nothing that can stop you, regardless of your gender, your background, or anything about you. They're blind to the person who created them.
Jonna, thanks for that, and we will say goodbye.
Thanks, Jeff.
I hope you enjoyed our discussion today with Jonna. Head on over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player. Tune in next week when we talk with John, who's an electrical engineer working on drones. Until next week, I hope this chat has helped ignite your passion towards a STEM career.